Our approach, engaging minds, helps students think creatively and solve problems strategically. It helps them to connect with the context, visualize strategies, apply learnings, and bridge the gaps. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here. Let us now enjoy the class with Abhinav.
Hi Abhinav, how are you doing?
I'm good. How are you?
Very good, very good. So Abhinav, today what do you want to do?
The irrational and complex root theorems of zeros.
Rational and complex roots, theorems, and zeros. Okay. Can you share with me what you have, and then we'll work on that.
Yeah.
So it is irrational and imaginary roots theorems, right? Irrational and imaginary roots theorem. Okay. So what are irrational numbers?
Numbers that like it's not like a fixed integer. You can't like graph it or anything.
Correct.
No, it's
No,
like
no,
a
no, no,
non.
no, no. Irrational numbers, let's say denoted by q bar, where q is a rational number. Irrational number cannot be written as p by q. Those are irrational numbers. For example, square root of 2, right?
Yeah.
So they have decimals which are not repeating. So if you convert to non-repeating decimals, is that clear to you?
Yeah.
So they are irrational numbers. So when you have square root 2, square root 5, right? Square root 4 is not irrational. Square root 4 is 2, right? So that is
Yeah.
rational, right? Pi is irrational, e is irrational. So these are examples of irrational numbers. Is that clear?
Yeah.
Now, the second part is to figure out imaginary roots. So imaginary roots means, uh, well, if I have x squared plus 1 equals to 0, then what is the value of x for which this is equal to 0? You will say x squared equals to minus 1, and then x is equals to plus minus square root of minus 1, correct?
Yeah.
However, square root of minus 1 is not real, right?
Yeah.
Not real. So we say it is an imaginary number. Imaginary number has this iota or I whose square is minus 1. You get the idea?
Yeah.
So therefore, square root of minus 1 will be I, right? So I is square root of minus 1. You get the idea?
Yeah.
And whenever we find roots in such functions, they are always complex conjugate. There are always two. Do you see this portion plus and minus here, right?
Yeah.
That means we have complex roots are in pairs, conjugate pairs. You get this idea?
Yeah.
Conjugate pairs. It means I will come with plus and minus I. That is the whole idea, right? So that gives you the understanding of the topic itself, right?
Yeah.
And what does this theorem say? What does this theorem say?
Like if like a polynomial, it can have for example, if it's x to the power of 4, it has 4 roots, and it can have complex zeros, real zeros, or imaginary zeros.
So if
Complex
degree is, yeah. So if degree is n, then there are n roots, correct?
Yeah.
If degree is n, there are n roots. This is what the theorem says. These roots could be real or imaginary.
Yeah.
Also, if imaginary roots are there, they always exist in pairs, which we say conjugate pairs. Is that clear to you?
Yeah.
Right. And we also know about one more term, which is multiplicity, right? Sometimes we have like x minus 1, more than one root at the same point, right?
Yeah.
Yeah. So that becomes the important thing. How do you know for a quadratic equation that we do not have a real root? You know by checking b square minus 4ac, right?
Yeah.
If it is greater than 0, then we have two roots. If it is greater than equal to, then we have one root with multiplicity of 2. Imaginary roots are there when this discriminant is less than 0. Is it okay? We call this discriminant D. We'll write it at D in today's exercise.
Okay.
So the discriminant b square minus 4ac actually decides whether we have real roots or imaginary roots. Is that clear to you?
Yeah.
Okay. So let's clear this and try to understand. The very first question, how many roots will it have? So let's make kind of a table. One question, number of roots, right? Number of real roots and number of imaginary roots. So degree 2 means number of roots are 2, correct?
Yeah.
Highest degree is 2. Total number of roots, right? And what is the, find the discriminant, b square minus 4ac, what do you get? Is it greater than or is it less than 0?
Greater than.
Greater than 0 means 2 real roots.
Yeah.
So real roots are 2 and therefore imaginary none, correct? So that is how we'll answer these questions. Is that clear to you?
Yeah.
Second question, degree 4. How will you do this? I will suggest, think like you may do like substitute like x square equals to y. Then you get a quadratic equation, right? Y
Yeah.
square minus 9y plus 18. You can factor this. So 6 and 3. So y minus 6 times y minus 3. And y is x squared. So you could write this as x squared minus 6 times x squared minus 3. And that gives you 4 roots, right?
Yeah.
All real. So x is equals to plus minus square root of 6 and also plus minus square root of 3. So we have 4 real roots in this case. Total roots all are real, right? All real.
Yeah.
Now, can you do question number 3? So let's factor. $35.
So it has 5 real roots.
You're right. X equals to 0 is one real root. X equals to plus minus square root 35 and x equals to plus minus 1. How many irrational roots, tell me?
0.
2 irrational. These 2 are irrational.
Oh.
Right? Square root
Yeah.
35. Here, in the last example, we had 4 irrational roots. Irrational numbers are also real numbers. You understand what are real numbers, right? real numbers include both rational and irrational.
Yeah.
Okay. In fact, the question only is asking real and imaginary, but I'm telling you rational, irrational because the topic had irrational word in it. So just in case, they put how many irrational, you should be in a position to answer. Is that clear?
Yeah.
Okay, so let me erase. Okay, we can continue. Next question. F of x is 3x cubed plus 2x squared minus x. Let's do what we did in example 3 and see what do we get. So we get this as equal to x is common again. So 3 minus 1. So you have to 3, you need 1, so 3 and 2, right? So plus 3 and minus
3 real roots.
Question number 5, 3 real roots, correct? Question number 5, can you factor this?
I think you can.
You can replace x cubed with y, for example, right? As far as the number goes, 27, 208, 64, do they have anything common? 6 and 4 is 12, so 3 is definitely common, 9 is not there. 208 is not a multiple of 3, so no number is common. So we could write this as 27. Y, I'm putting y cube as y as x cube, right? So y squared plus 208y minus 64, correct?
Yeah.
Find the discriminant for this. Is it positive or negative? B square minus 4ac.
It's positive.
Greater than 0. That means we have real roots. Is that okay?
Yeah.
Real roots. Okay. How many real roots? What is the discriminant? Can you factor this now using a discriminant?
Yeah, the discriminant is greater than 0.
Okay. What is the value and how can you find the roots? 27 into 6. So we find sum and product.
But 64, right? Not 6.
Oh, 64. Okay. Okay. Can you factor this? Find the roots using the quadratic formula.
Okay.
Minus b plus minus square root of p square minus 4ac over 2a. You will get the roots.
Yeah. Okay. One root is 8 over 27.
Can you write this in factored form?
Yeah.
Tell me what you get.
Oh, factored form. I use quadratic formula.
Yeah, so what roots do you get?
Okay, one of them is 0.29. Repeating.
No.
0.
No, tell me the exact value with square root, radical sign.
Oh, okay. It is negative 208 plus or minus plus or minus square root of 50176 over 54.
Okay. So, correct. So, anyway, so we do get irrational roots for this. So, what are the two roots? Can you give me decimal value?
Okay. One of them is 0.296 repeating. And the other one is -8.
-8.
Yeah.
So, -8 will result into factor of x plus 8. You see that?
Yeah.
And that minus 0.296 will have a factor of 0.296, correct?
Yeah.
Now, so that becomes your value. And what you could do here is you can take 27 outside to write like this, right? Now, as far as y plus 8 is concerned, this portion is actually x squared, in this case x cube, because y is x cube, right?
Yeah.
X cube plus 8. You see that?
Yeah.
The other one is x cube minus, let's say, 0. Other factor is x cube minus 0.3, correct?
Yeah.
Approximate. Because we are only interested in finding number of roots, not the roots.
Yeah.
So x cube plus 8 is like equal to x plus 2 times x squared minus ab, which is 2x plus 4, correct? That is how you will factor it.
Yeah.
The other factor, x cube minus 0.3, can be factored as x minus 0.3 times x squared, product of this as plus 0.3x, and then you have 0.3 square is 0.09. Is it okay?
Yeah.
Now look here. We have actually split this degree 6 to 1, 2, 3, 4. And you can see from here, it does have 6 roots, right?
Yeah.
Out of these 6 roots, 2 of them are real.
Yeah.
And 4 are imaginary.
Okay.
Because that component, which is x square minus 2x plus 4, will give you imaginary roots.
Okay.
You get the idea?
Yeah.
Correct. So that is how we are going to answer this particular question. Clear?
Yeah.
Okay. Want to take a picture of this? You can take, and then we'll move on to the next question.
Okay. Yeah, I took it.
Can you factor question number 6?
No, you can't. We can factor by grouping, right?
Yeah, we can factor by group. So let's do this. Slightly complicated question. So we'll rewrite this as 27 x to the power of 9 minus 27 x cubed as one, and the other one is plus 8 x to the power of 6 minus 8. So when you factor 27 x cubed is common, you get x to the power of 6 minus 20 minus 1. The other factor is 8 common, x to the power of 6 minus 1 is common factor.
Yeah.
Now you can take x to the power of 6 minus 1 as a common factor. You get 27 x cubed plus 8.
Yeah.
Now this could be factored x cube, x to the power of 6 could be treated as x square cube. You understand?
Yeah.
So we could factor this as, let me rewrite this as x cube plus 1 times x cube minus 1. So that is the factoring of x to the power of 6 minus 1. Is it okay?
Yeah.
The other factor is 3x cube plus 2 cube. So it could be written as 3x plus 2 times square of 3x, which is 9x squared, and product of these two plus 6x square of 2, which is 4. That is how you could factor this.
Minus 6x, right?
Oh, yeah, you are right. Minus 6x. Good job. Thank you. Minus 6x. Now, you know, the first two factors can be further factored, x cube plus 1. So let's factor them. So we get x plus 1 times x squared minus x plus 1. And then we have x minus 1 times x squared plus x plus 1.
Yeah.
And then we have these two factors, 3x plus 2 times 9x squared. 9 times 4, 36. We want minus 6. Most probably, you can try discriminant for that. Maybe you cannot 9x squared minus 6x plus 4. Just to be sure, just try discriminant. Otherwise, you know it will be imaginary. B square minus 4ac. So b square is 36. Minus 4ac, it is negative, right? So it gives you imaginary roots. So how many real roots we have? Real roots are 1, 2, 3. 3 real roots.
Yeah.
And imaginary roots are 2, 4, 6. Is that clear to you?
Yeah.
But that is your working to show how many real and how many imaginary roots you can have. Is this concept clear to you?
Yeah.
So we've done the first set of 6 questions. That's great. Let's move on to the next set of questions. Yeah, you can move your page and then we'll move on to the next set of questions. Can you please read this question now?
A polynomial function with rational coefficients has the following zeros. Find all the additional zeros. -5, I.
So I cannot be alone. So negative I will be another zero. Is that clear to you?
Yeah.
Right. Next.
-1 plus I, radical 5.
So negative 1 minus I and radical 5 will also be plus and minus, right?
Yeah.
So that is also there. Is that clear to you?
Yeah.
Next.
-3 plus radical 5, -I.
So these are the additional two roots because they always exist in pair. So irrational roots and imaginary roots always are in conjugate pairs. Absolutely clear?
Yeah.
Based on this, we have only one here, -2 minus -10 as the additional root here, right?
Yeah.
Last, this one, -2 minus square root 5. Now you know, right?
Yeah.
So in this case, 2 minus 2i. So it is 2 plus 2i. 1 minus 2i. And 1 plus 2i is already given. So that is okay. So only 2 plus 2i is missing. Is it okay?
Yeah.
So now when they say multiplicity of 2, that multiplicity means there are two roots of the same value.
Yeah.
So that means 2 minus this. So that means there are two missing roots of plus, right? Do you see that?
Yeah.
So it is at degree 4 equation.
Yeah.
So square root 5 multiplicity means 1 and 2, 3, 5 degree equation.
Yeah.
Correct. So we're done with this set. Can we now look into the next question number 15 onwards? What is the question? Please read
Write
the
a polynomial. Yeah. Write a polynomial function of the least degree with integral coefficients that has the given zeros.
Correct. So we'll use 1 as our integral coefficient. So the polynomial could be, these are the roots, right? So for 0, it is x, and then we have x minus 2, and the square root 3, we have x plus minus, right?
Yeah.
Okay? So we could write x plus minus square root 3, or we could write x plus x square plus 3. Is it okay?
Yeah.
So x square plus 3 will give us two roots plus minus square root 3.
Yeah.
So that will be your equation for 15. The next one.
Okay. It's x squared minus 3, right?
No. If I do minus 3, then you have plus and minus square root, right?
Oh, okay.
Oh, yeah, you're right. Minus 3. Yeah. In this case, minus 3. Sorry. Yeah, because you have plus and minus square root 3. Yeah. I was thinking differently. Yes, minus. Correct. Let's clear this. Let me correct my thing. You're very right. X times x minus 2 times x square minus 3.
Yeah.
Because there are two roots. Right. Next one. X plus 5 times x square minus 3. Correct. Can you do 17? Tell me.
Yeah. So x plus 1, x minus 2i, and then x plus 2i.
So that means x square plus 4 square root. Is it okay?
Yeah. And then x squared plus 4. X squared minus 4, right?
So for this, what we do? There are actually two roots. One is 2 plus 2i, the other one is 2 minus 2i. Is it okay?
Yeah.
So you could also write like this. One factor is x minus 2 plus 2i, right?
Yeah.
Times x minus 2 minus 2i, right?
Okay.
You could think like this. So
Yeah.
that could be your factor, but in the factor form, you're not writing imaginary numbers, correct?
Yeah.
So when you expand this, what do you get? Try to do this.
Okay.
Expand this, simplify.
Yeah.
So you could group them like this. Do you understand? So a square minus b square. So you get this as x minus 2 whole square minus 2i whole square. So, and now you expand x square minus 2ab, which is 4x, plus 4 minus 4 I square will give you positive. So you get x square minus 4x plus 4 plus 4. So which is x square minus 4x plus 8. So this term will be written as x square minus 4x plus 8.
Okay.
So you have this answer as x square plus 4 times x squared minus 4x plus 8. Is that clear?
Yeah.
Let's do the next one. Question
You can
number 19, right? Try to do it.
Yeah. So it'll be x squared plus 4, and then
Then you need to figure this out, right?
yeah,
X
x minus 2 plus radical 2, and then x minus 2 minus radical 2.
Yes. Expand, simplify.
Okay.
So x minus 2 whole square. X minus. And minus this square. That is a fact.
X squared minus 4x minus 4.
Correct. So that is your answer. You get the idea, right?
Yeah.
So that is how you do this. Let me rewrite here. X square plus 4 times x square minus 4x minus 4 is what the polynomial will be. Correct?
Yeah.
Last question.
Okay. Square root of 6 and negative 3 plus square root of 5. Squared minus 6 and x squared plus 6x plus 4.
Correct. Correct answer. So you know how to do it now. Perfect. That's great. Very good job. Move on to the next set of questions. Yes. Can you please read question number 21?
Yeah. Write a polynomial function of the 5th degree with integral coefficients that has 2i and a 0.
With integral coefficient that has 2i as a 0, right? So you want 2i as a real 0, that means your factor will be x square plus 4, right?
Yeah.
So that becomes definitely one factor which ensures 2i as a 0. Degree 5 you want, so you can add anything to this for degree 3, right? So you can have x plus 1 times x plus 2 times x plus 3, anything you could write. Is it okay?
Yeah.
But the first part is important. So that becomes degree 5 polynomial.
True or false? A polynomial function of third degree with integral coefficients can have 2 and 2i as zeros.
So 2 is 0 means x minus 2. 2i is 0 means x square plus 4, correct?
Yeah.
That is it. Now coming back to question number 21, we could give a very easy answer as x square plus 4 takes care of 2i, right? And
Yeah.
you want fifth degree, so you want a cubic equation. So we'll add x cube minus 1. You understand? So
Yeah.
that is a cubic equation. So we have a simple equation which will give us both the conditions. It is degree 5, correct?
Yeah.
And it satisfies the root 2i. Is that clear to you?
Yeah.
So we can actually, now you've understood, you can summarize today's learnings. We'll stop sharing.
Okay.
Can you summarize today's learning? What did you learn in today's exercise?
So we learned about irrational roots and complex roots of polynomials and how to find if there are irrational roots and how to find how many different roots a polynomial can